Hello dear students, how are you? You are all safe and happy. Today inshallah we will continue on lesson about states of matter. So last time we said that all matters have three main states: solid and liquid and gas. So actually we are done with this lessons, but today we are gonna just answer some questions from the lesson review. So let us start with the visual summary of our lesson. So the first question here: solids can easily change in volume. What do you think, guys? True or false? Solids can easily change in volume. Is it easy to compress or to expand solid? What do you think? Okay, well, it's false. It's not easy to change the volume of solids. Okay, so the second state, as you can see here from the photo, this photo represents the liquid state. You know, as we can see here, small spaces between the particles, right? So the question is: liquids take the shape of their container. Is it true or false? What do you think? Yes, true. Liquids take the shape of their container. Why? Because as we can see here, there are small spaces between the particles, which will make them able to slide past each other out of the wall. So, number 3, the particles in gases move freely, as we can see here in this photo. This is the main idea. The question says: when the distance between gas particles increase, the volume of the gas increase. True or false? Okay, true. Then if the distance between the particles increase, the volume of the gas will increase. And if we want to decrease the volume, what should we do? Yes, we will decrease the distance between these particles. So here we need to review some of that vocabularies. What do we mean by solid? What do we mean by liquid? What do we mean by gas? So the question is: draw a line to connect the following terms to the description of their particle motion. So what do you think, guys? Solid. What is the term that best describes solid? In solid, particles are close together and locked in place, or particles are far apart and can move freely, or particles are close together and can slide past each other. Well, it's A. In solid, particles are close together and tightly attached to each other, and they are locked in place. That's why we say that solid has a defined volume and a defined shape. Then number 2, for liquid, how can we describe the motion of the particles in liquid? Guys, particles are far apart and can move freely, or particles are close together and can slide past each other? Yes, it's C. Particles are close together and can slide past each other. Well, what about 3? Gas. For gas, as we said, particles are far apart and can move freely everywhere in any direction. So for question number 4, define what is the kinetic theory of matter. Guys, the kinetic theory of matter states that all matters are made up of small particles, and these particles are in a continuous motion, and the motion of particles in these substances determine their states of matter. So maybe I will write the answer for you here. So guys, here is the answer. It states that motion of particles in a substance determine its matter, or its state of matter. Okay, let's change the color of answer. Alright. So guys, next question, number 6. What could you do to change the volume of a gas? We already described about this point, guys. You remember? If I want to change the volume of a gas, what should I do? Well, yes, we maybe increase or decrease the distance between the particles, or between the gas particles. Okay, so suppose, for example, we have this container right here, and this container is full of gas particles. So small balls here represent gas particles. Okay, so now, okay, we need a number of gas particles right here. Okay, one more. Well, so here are the particles of gas. As we can see here, the distance between the particles are very big. Okay, so suppose the container was smaller this way, and now I am asking you to change the volume of these gas. Suppose we want to increase the volume of this gas. What should we do, guys? Okay, we need to what? We need to increase the distances between the gas particles. So we need to increase the volume of the container, and this way the particles of gas will move far apart from each other, and this way we can see that the distances between the gas particles increased. Okay, suppose we want to decrease the volume of the gas. What should we do? Exactly the opposite. We need to decrease the distances between the gas particles this way. So here we are compressing the gas by decreasing the distances between the particles this way. So I decrease the volume of the container, and the distances between the gas particles decreased, as we can see here, and so on. So what could you do to change the volume of a gas? To change the volume of a gas, we can either increase the volume of the container or decrease the volume of the container. So guys, here is our answer for this question. Now let us move to the next question. Question number 7. Question number 7 says, can a tank of oxygen gas ever be half empty? Explain. So to understand this question, let us try to draw a container of gas, and this container should be half filled of gas. So we need gas particles inside here. Okay, we need a number of these gas particles. Let's see, this way. Okay, alright, so we have here 5 gas particles. So guys, the question says, again, can a tank of oxygen gas ever be half empty? This way. So half of the tank will be filled with the gas particles while the other half is empty. What do you think, guys? Can we have a tank that is half empty of gas? Well, yes, the answer would be no. We can never have a tank of gas that is half empty. Why? Then explain. So yes, the answer will be because, as we described before, that the gas doesn't have a defined volume. Why? Because actually the particles like to move freely and like to stay far apart from each other. It's like if you hate somebody and you don't want to get closer to him, so you will try your best to move far as much as possible. And this is exactly what's happening with the gas particles. They don't like to stay close to each other. They like to stay far apart from each other as much as possible. So whenever you increase, for example, the volume of this container, they will move more and more far apart from each other. Again, if you increase it more, the distances between the particles will also increase and they will keep moving far away from each other, and so on. So you will never have a space that is empty from gases, because as we see, the gas particles like to move freely everywhere, and they will always fill the container that they occupy. So guys, here is the answer. No, the gas particles always move freely and fill the volume of the tank, as we explained. So now let us move to the next question. Question number 10 says the particles that make up a rock are constantly in motion. However, a rock doesn't visibly vibrate. Why do you think this is? So you remember, guys, we say that the particles of any solid matter are locked in their place, but still they can move, but their movement will be very, very small, and we call it vibration. They will vibrate in their places. So actually the particles of solid matter can move, but this vibration actually or this movement or this motion are so small to be detected. That's why we cannot recognize it. Okay, so guys, here's the answer. The vibration of all the particles is too small to detect by simply viewing the rock. So guys, today we almost answered most of the questions except for question number 8. I need you guys to answer it. Actually, question number 8 and 9, and inshallah they are gonna be so easy for you, so please try to answer them. And that's all for today. Thank you, and see you tomorrow, inshallah.